any time today, a Soviet-era spacecraft is expected to fall to Earth. The half-ton craft is known as the Kosmos 482. It was created to land on Venus, but has spent pretty much the last 53 years floating in Earth's orbit.
Remember Kosmos 482, the Soviet spacecraft that failed to complete its mission over half a century ago? For 53 years, it has been quietly orbiting Earth, and now it's making an unexpected return, sparking interest among space watchers. Originally launched as part of a Venus mission, Kosmos 482 never made it out of Earth's orbit due to a launch failure. Now, decades later, it's on track to re-enter the Earth's atmosphere. Will its return be seen as a relevant moment in space history, or a resurgence of embarrassment for the former Soviet space program? Introduction. In the vast and often unpredictable history of space exploration, some missions stand out not for their success, but for their strange, almost legendary failures. One such mission is that of Kosmos 482, a Soviet-era spacecraft that was launched with high hopes but ended up as a long-forgotten piece of space junk, until it unexpectedly became relevant again, decades later.
Some pretty sketchy space junk that could come crashing down this weekend in a big way.
Originally intended to travel to Venus as part of the Soviet Union's ambitious Venera program, Kosmos 482 never left Earth's orbit. Instead, it became a ghost of the Cold War, silently circling the planet for more than 50 years. Launched on April 3, 1972, Kosmos 482 was supposed to be the Soviet Union's next big step in exploring Venus. It was part of a long-running effort known as the Venera program, which had already seen several triumphs and failures in its attempts to study the second planet from the Sun. The Soviets had been working for years to understand Venus's hostile environment, with its scorching temperatures, crushing atmospheric pressure, and mysterious cloud cover. The plan for Kosmos 482 was to send a lander that could survive on the planet's surface long enough to transmit valuable scientific data, something that very few probes had managed to do at that point. The mission was technologically ambitious and politically significant, aimed at showcasing Soviet prowess in deep space exploration during a time when the US and USSR were constantly trying to outdo one another. However, things didn't go according to plan. Due to a malfunction during the launch phase, Kosmos 482 failed to escape Earth's gravity and was trapped in a lower orbit instead of heading toward Venus. To cover up the failure and keep the mission's details vague, the Soviet Union reclassified it under the generic Kosmos label, which they often used for military or failed missions. On paper, Kosmos 482 became just another Earth-orbiting satellite, but its story was far from over. Importance in space history and recent relevance. At first glance, Kosmos 482 might seem like just another Cold War mishap, another forgotten relic of a time when the two global superpowers were constantly launching things into space. But its significance runs deeper than that. For one thing, the spacecraft's design was incredibly advanced for its time. The descent capsule was built to withstand the brutal conditions of Venus's surface, which meant it was practically overbuilt for Earth orbit. This heavy-duty construction is likely the reason why parts of Kosmos 482, especially the descent module, have managed to survive in orbit for over 5 decades.
This object is designed to survive re-entering Venus, which is a whole lot harsher than Earth.
In fact, some of the spacecraft actually crashed back to Earth just 2 days after launch, landing in New Zealand and causing a stir among local authorities and the international media. This unexpected re-entry of space debris was one of the first known cases of its kind and highlighted the growing problem of orbital clutter, a topic that is even more relevant today with the increasing number of satellites being launched into space. What makes Kosmos 482 especially interesting now is the fact that its descent capsule is still orbiting Earth, and experts before believe it could re-enter the atmosphere sometime in the near future. Its longevity and potential for re-entry have reignited interest among space historians, engineers, and even amateur satellite trackers. It has become a living artifact of Cold War-era space design, still circling above us like a time capsule from the 1970s. In a way, Kosmos 482 symbolizes the persistence of human ambition and error. Even though it failed to reach its intended destination, it continues to be part of our planet's orbital history. An unintended reminder that not everything launched into space ever truly disappears. Kosmos 482 was born out of one of the Soviet Union's most ambitious and scientifically driven space initiatives, the Venera program, a series of missions aimed at exploring Venus, the closest planet to Earth in terms of size but vastly different in its brutal environmental conditions. By the early 1970s, the Soviet Space Agency had already conducted several flybys and lander attempts, many of which ended in failure. Still, the USSR was determined to crack the code of Venus's dense atmosphere and scorching surface, and so they launched a new duo of probes in 1972, Venera 8 and its lesser-known sister craft, Kosmos 482. Both spacecraft were equipped with descent modules designed to survive for short periods on Venus's surface, gathering and transmitting data on temperature, atmospheric pressure, chemical composition, and surface light levels. The idea was to advance the Soviet understanding of Venus while also proving their technological capabilities in deep space exploration. Kosmos 482 was scheduled for launch on April 3, 1972, just 2 days after Venera 8 successfully lifted off. The two probes were essentially twins, similar in design, engineering, and mission goals. The timing was deliberate. Launching in pairs gave the Soviets a better shot at success, especially with such a difficult target as Venus.
And finally, the hard work of many teams to create Venus Station is 8.
If one failed, the other might still accomplish the mission. Venera 8 did, in fact, go on to make history by landing on Venus and transmitting valuable data for over 50 minutes before succumbing to the planet's extreme heat and pressure. Kosmos 482, however, never got the chance. It was supposed to follow the same trajectory, break free of Earth's gravity, and begin its journey across the solar system. But instead of reaching interplanetary space, Kosmos 482 suffered a failure during its final engine burn and remained trapped in Earth orbit. Its scientific instruments, its reinforced descent capsule, and its mission objectives were all designed for Venus, but they never left the planet's backyard. Let's have a clearer explanation on what actually went wrong during the launch. Do you have a complete idea? The turning point in the story of Kosmos 482 came almost immediately after launch. Everything started according to plan when the spacecraft lifted off on April 3, 1972, riding atop a Molniya M rocket, a launch vehicle commonly used for interplanetary missions at the time. The early phases of the launch went smoothly, but the critical final step, a burn from the upper stage of the rocket meant to propel the probe beyond Earth's gravitational pull and toward Venus, failed. The exact cause of the malfunction remains uncertain, likely due to a guidance or timing error in the final boost, but the result was clear. Kosmos 482 never achieved escape velocity.
A Soviet-era spacecraft has plunged to Earth more than half a century after its failed launch to Venus.
Instead of entering a heliocentric orbit that would intersect with Venus, it was left stranded in low Earth orbit, a place it was never designed to stay. Even though the rocket had failed to send it to Venus, the spacecraft still separated from the upper stage, as it was programmed to do. Unfortunately, this meant that the probe entered an unintended orbit on its own, essentially drifting as high-tech space debris. Normally, after this phase, the spacecraft would begin adjusting its orientation and preparing for its long journey to Venus, but that process never began. Since the mission parameters were based on a Venus landing, Kosmos 482 systems had no purpose in Earth orbit, and without a functioning propulsion system or guidance correction, it became just another object circling the planet. The Soviets, following standard practice when missions failed to leave Earth's orbit, gave it the catch-all designation of Kosmos, turning what was meant to be a deep space scientific mission into a quietly shelved mistake. What made the situation even more unusual was the fate of the descent module, the section of Kosmos 482 designed to survive the harsh Venusian environment. Built like a tank, it was engineered to withstand pressures over 90 times that of Earth's atmosphere and temperatures hot enough to melt lead. Instead of touching down on Venus, this rugged lander remained attached and stuck in orbit. A Cold War relic in the sky.
Kosmos 482 was part of the Soviet Venera program and got stuck in Earth's orbit.
For more than 5 decades, Kosmos 482 has silently orbited Earth, a forgotten relic from a different era, one when the Cold War's reach extended far beyond the planet's surface and deep into space. Trapped in orbit since its failed launch in 1972, the spacecraft has become a kind of time capsule, silently circling the Earth and serving as a physical reminder of both Soviet ambition and the high-stakes competition of the space race. What sets Kosmos 482 apart from the countless other satellites launched since is not just its age, but the sheer resilience of its construction. Designed to endure the hellish conditions of Venus, crushing atmospheric pressure, extreme heat, and chemical corrosion, its descent capsule was built with extraordinary durability. Throughout the years, Kosmos 482 has captured the attention of amateur astronomers, satellite trackers, and space historians, many of whom consider it an oddity worth keeping an eye on. Though it no longer functions in any operational sense, its orbit has been occasionally tracked and analyzed, especially as concerns about space debris have grown in recent decades. Space agencies also monitor large debris objects like Kosmos 482 for the sake of orbital safety, particularly due to the risks of potential collisions with active satellites or even space stations. While its orbit has decayed slowly over time, the descent capsule remains stubbornly aloft, its dense structure resisting atmospheric drag in a way that most older satellites cannot match.
It never made it out of Earth's orbit, instead circling the planet in an irregular pattern.
Kosmos 482's prolonged presence in orbit makes it a classic example of early space junk, a growing problem that modern space missions must now contend with. In the 1970s, there was little long-term thinking about what would happen to defunct spacecraft or upper rocket stages once their missions ended. Back then, the focus was almost entirely on mission success and national prestige. Today, Kosmos 482 is a case study in the long-term consequences of launching durable objects into space without a plan for deorbiting them. It's not dangerous in the immediate sense, but it is a reminder that once something is put into orbit, it tends to stick around, sometimes for generations. In that sense, Kosmos 482 is more than just space junk. It's a floating Cold War monument circling silently above our heads, embodying a forgotten chapter of planetary exploration and the enduring legacy of space ambition without cleanup. Well, it's not long forgotten after all. This year was the year when a memory has been relived. This time, the remaining debris is coming back to its real home. Could you believe it made it after 53 years? May the 10th, 2025. The fall to Earth. On May the 10th, 2025, a piece of space debris made its return journey to Earth, re-entering the atmosphere in a fiery descent that marked the end of its time in orbit. This kind of event isn't uncommon. Earth is constantly being buzzed by falling remnants of old satellites, rocket stages, and other space hardware. What made this one stand out was the size and international attention it attracted as it made its way back down. According to tracking data, the object most likely broke apart high above the Indian Ocean. This is pretty typical for large pieces of space junk.
Russia's space agency believes the Kosmos 482 lander made an uncontrolled re-entry over the Indian Ocean.
As they re-enter, the intense heat and pressure of Earth's atmosphere usually causes them to disintegrate well before they hit the surface. In this case, there were no reports of any debris making it to land, and no damage was recorded. So while it made headlines briefly, the event turned out to be relatively harmless. The re-entry was closely monitored by the European Space Agency, ESA, along with several international tracking organizations. These agencies use a mix of radar, satellite tracking, and predictive modeling to keep tabs on objects in orbit, especially when they pose even a small risk of coming down over populated areas. In this case, they kept the public informed and reassured, and everything went according to expectations. While the dramatic-sounding fall to Earth might spark visions of a flaming wreck streaking across the sky, re-entries like this one are usually more routine than they sound. Most of the time, nature takes care of cleanup, burning up the debris long before it gets anywhere close to the ground. The general success and discoveries of the Venera program. The Venera program, launched by the Soviet Union in the 1960s and continuing into the 1980s, was one of the boldest and most groundbreaking space exploration efforts in history.
A Soviet-era spacecraft has plunged to Earth more than half a century after its failed launch to Venus.
Its goal was simple in theory, but incredibly complex in practice. Send spacecraft to Venus, the planet often referred to as Earth's sister, and uncover its secrets. But unlike Mars, with its cold deserts and thin atmosphere, Venus turned out to be a hellish world, blisteringly hot, shrouded in thick clouds of sulfuric acid, and covered with crushing atmospheric pressure. Despite these challenges, the Venera missions not only pushed the limits of space engineering, but also delivered some of the first, and still rare, images and data from the surface of another planet. One of the most impressive aspects of the Venera program was its persistence. The early missions were plagued with failure, with many probes either missing Venus, crashing, or being destroyed by the planet's extreme conditions. But with each setback, the Soviets improved the technology, learning from what went wrong. Eventually, they got it right. Venera 7 in 1970 became the first spacecraft to successfully land on another planet and transmit data back to Earth. It only survived for 23 minutes on Venus's surface before being destroyed by the heat and pressure.
So it's going to be about 700 pounds, and most of that is actually fuel to get it to Venus.
But that short transmission was a major breakthrough. Later missions like Venera 9 and Venera 13 not only survived longer, but managed to send back the first black and white and color photographs of Venus's surface. These were haunting images of flat, rocky plains under a dense yellow sky, proof of just how alien our neighboring planet truly is. The discoveries made by the Venera probes completely changed what scientists thought they knew about Venus. They confirmed that the planet's surface temperature was hot enough to melt lead, reaching around 465 degrees Celsius, 869 degrees Fahrenheit. The atmosphere was revealed to be over 90 times denser than Earth's and composed mostly of carbon dioxide, making Venus a textbook example of a runaway greenhouse effect. These findings have had a lasting impact on how scientists understand climate science and planetary evolution, even influencing models of Earth's own potential future under climate change. Beyond the data and images, the Venera program was a technical triumph. It demonstrated that it was possible to build spacecraft capable of operating, even if only briefly, in one of the most hostile environments in the solar system. This was no small feat.
Now, all this has happened after scientists recently discovered that the planet Venus contained phosphine gas.
The landers had to be designed like miniature tanks, with heat shields, pressure vessels, and electronics that could function under conditions that would destroy most modern machines in seconds. Venera engineers were decades ahead of their time in dealing with high-pressure systems and extreme thermal resistance, and many of their designs still influence planetary probe development today. In the broader story of space exploration, the Venera program holds a unique place. While the United States was making headlines with moon landings and Mars rovers, the Soviets quietly became the first, and so far only, nation to land and operate spacecraft on Venus's surface successfully. Their missions filled in a crucial piece of the puzzle in our understanding of the solar system and proved that no planet, no matter how extreme, is completely out of reach. Though the program ended in the 1980s, its legacy lives on, not just in the data it returned, but in the spirit of exploration it embodied, bold, unflinching, and determined to go where no one had gone before, Soviet space explorations, after the Venera program. After the success of the Venera program, the Soviet Union didn't slow down in its pursuit of space exploration.
The first missions to explore the Earth's neighbor were carried out by the Soviet Union.
While the golden age of Venus exploration had passed, the Soviets kept their sights set on new goals and continued to push the boundaries of space science and engineering. After the legendary Venera series, the Soviet space program didn't slow down. Instead, it leveled up with the Vega missions, launched in 1984, which can be seen as the spiritual successors to Venera, but with an extra twist. Vega 1 and Vega 2 were bold, dual-purpose missions that targeted two very different destinations, Venus and Halley's Comet. This clever combo of planetary science and cometary exploration made Vega one of the most ambitious and innovative space efforts of its time. The missions kicked off with a visit to Venus, where the spacecraft deployed two kinds of payloads, traditional landers and a new, groundbreaking idea: atmospheric balloons. These balloons were designed to float within the dense, cloudy atmosphere of Venus, riding the planet's powerful winds like weather balloons on Earth. It was an incredibly creative approach to data collection. While the landers descended to the surface to perform short-lived but intense studies of the scorching terrain, the balloons hovered at about 54 kilometers above the surface, transmitting valuable atmospheric data for around 2 Earth days. These drifting observatories measured things like temperature, pressure, wind speeds, and cloud particle composition, all while surviving in one of the most hostile environments in the solar system. Once their job at Venus was complete, the main spacecraft didn't just call it a day. They continued their journey toward Halley's Comet, making Vega the first mission in history to combine planetary exploration with a comet flyby. In 1986, both Vega spacecraft successfully passed close to the famous comet, capturing some of the first ever detailed images and measurements of a comet nucleus. These close encounters helped confirm the dirty snowball model of comets, a mix of dust, rock, and ice, and provided valuable data on cometary gas and dust emissions, magnetic fields, and solar wind interactions. The Vega missions were a major technological and scientific triumph. They showed the USSR was still a major force in space exploration, capable of pulling off complex multi-target missions. By bridging planetary science and cometary research, the Vega program expanded our understanding of two very different types of celestial bodies in a single mission framework. Today, the Vega missions stand as a shining example of how creativity, engineering, and bold thinking can push the boundaries of what's possible in space. The Phobos program was one of the Soviet Union's most ambitious interplanetary efforts, aimed not just at Mars, but specifically at its enigmatic moon, Phobos. The plan was to launch 2 spacecraft, Phobos 1 and Phobos 2.
Last year, the Soviets launched 2 spacecraft to the planet, both named after the Martian moon, Phobos,
that would orbit Mars, study the planet and its environment, and then deploy landers to the surface of Phobos itself. At the time, this was cutting-edge stuff. Few missions had even gotten close to Mars's moons, let alone attempted to land on one. Unfortunately, things didn't go entirely as planned. Phobos 1 never made it to Mars. A simple human error, a missing hyphen in a software command sent from Earth, caused the spacecraft to shut down its attitude control system, leading to total loss of contact. It was a frustrating and costly mistake, especially considering the sophistication of the mission. Phobos 2, however, did reach Mars and managed to carry out a significant portion of its mission. It entered orbit around the Red Planet in early 1989 and began transmitting valuable data back to Earth. The spacecraft conducted studies of Mars's atmosphere, surface temperature, and magnetic environment. It also captured some intriguing images of Phobos, including surface features that raised questions about the moon's composition and origin, just as it was preparing to release its landers, one of which included a mobile hopper that would have moved across the moon's surface, Contact with Phobos 2 was lost. The cause was likely a computer failure, which meant the landers were never deployed. Despite these setbacks, the Phobos missions highlighted just how advanced Soviet space engineering had become by the late 1980s. These missions included multiple scientific instruments, coordinated orbiter-lander systems, and innovative mission planning that rivaled anything being done elsewhere in the world at the time. While the full mission objectives weren't achieved, the Phobos program contributed valuable data on Mars and its moons, and it paved the way for future attempts to explore these mysterious Martian satellites. The success in space explorations have continued. Russian astronomers proved their excellence in science and space discovery through a series of trips out of the planet. Continued lunar missions. Lunar program's final years. The Soviet Union didn't abandon the moon after the US won the race to land humans there. Instead, they continued sending robotic probes to study and sample the lunar surface. The later lunar missions, like Luna 16, 20, and 24, brought back soil samples from the moon using automated sample return technology.
A happy landing for Russia's unmanned Luna 17 spacecraft and a big step forward for Soviet scientists in Lenin's Jubilee year.
Luna 24, launched in 1976, was the last Soviet mission to the moon and remained the last sample return mission from the moon until China's Chang'e 5 in 2020. These missions proved that robotic exploration could still accomplish a lot, even without humans on board. Salyut and Mir space stations. While robotic planetary missions often steal the spotlight, one of the most impressive and lasting contributions of the Soviet space program was its pioneering work in long-duration human spaceflight. In the 1970s and early 1980s, the Soviets laid the groundwork for sustained space living with a series of experimental stations known as Salyut. These early stations tested everything from docking procedures and onboard life support systems to the effects of zero gravity on the human body. Salyut missions helped cosmonauts adapt to the challenges of life in space for weeks and even months at a time, something that had never been done before. Building on those successes, the Soviets took a giant leap forward in 1986 with the launch of Mir, the world's first modular space station. Unlike the earlier Salyuts, which were single-piece stations, Mir was designed to be assembled in orbit, with multiple modules added over time. This allowed for a much larger and more versatile living and research environment. Cosmonauts aboard Mir conducted hundreds of scientific experiments in biology, physics, astronomy, and medicine, contributing significantly to our understanding of how long-term exposure to space affects both the human body and complex systems. Mir quickly became a symbol of Soviet, and later Russian, engineering excellence.
Mir's core module was launched by the Soviet Union on the 19th of February 1986.
It hosted a rotating crew of international astronauts and cosmonauts, some of whom stayed aboard for more than a year. The station demonstrated that humans could not only survive but live and work productively in space for extended periods, laying the foundation for future space habitats like the International Space Station, ISS. In fact, many of the design principles and lessons learned from Mir were directly applied to the ISS project. By the 1990s, as the Cold War thawed and the Soviet Union dissolved, Mir became a symbol of international cooperation. Russia began partnering with other space agencies, including NASA. American astronauts traveled to and lived on Mir as part of the Shuttle Mir program, an important stepping stone in US-Russia space collaboration. These joint missions helped build trust and operational experience that would later become crucial in the creation and ongoing success of the ISS. Mir remained operational until 2001, an impressive run for a station that had initially been expected to last only about 5 years. In its 15 years of service, it became a true orbiting laboratory, a training ground, and a testament to human resilience and ingenuity in space. Its legacy lives on, not just in the history books, but in every astronaut who now spends months aboard the ISS, following in the footsteps of those who first proved it was possible. Buran Shuttle Program. In response to the United States' highly publicized space shuttle program, the Soviet Union set out to create its own reusable orbital spacecraft. Enter Buran, a sleek winged spaceplane that looked strikingly similar to NASA's shuttle, but featured some impressive differences under the hood. Launched for its first and only flight in 1988, Buran completed 2 orbits of Earth and then landed entirely under automated control, a remarkable technological feat at the time. It became the first and only orbital spacecraft to perform a completely uncrewed, fully automated flight from launch to landing. Even today, few space vehicles can match that level of autonomy. Buran was part of a broader effort by the Soviet Union to keep pace with US advancements in space technology, but it was also more than just a copycat project. It incorporated its own innovations, such as a more powerful launch system, the Energia rocket, and a design that allowed for heavier payloads and better reusability potential. Unfortunately, despite the success of its maiden flight, the Buran program was abruptly cancelled in the early 1990s due to a perfect storm of factors: soaring costs, political upheaval, and the dissolution of the Soviet Union itself.
For over a decade, the Soviet Union had been secretly working on their own spaceplane, called the Buran.
The impressive spacecraft never flew again, and its prototypes now sit in museums or, tragically in some cases, have been lost to neglect. Still, the years following the iconic Venera program made it clear that the Soviets weren't content to rest on their planetary laurels. From attempts to land on Mars's moons with the Phobos missions to daring flybys of Halley's Comet via the Vega program, the Soviets pushed the boundaries of what unmanned missions could do. At the same time, back on Earth's doorstep, they were launching some of the most complex human spaceflight initiatives the world had ever seen, culminating in the construction and operation of Mir, the first true long-term space habitat. These missions didn't always go smoothly. Some failed entirely, others fell short of their full goals. But every attempt, whether it was a remote-controlled shuttle, a floating balloon on Venus, or a modular space station, showed a commitment to serious innovation, engineering skill, and a clear vision for the future of space exploration. Even as economic and political instability began to take its toll on the Soviet space program in the late 80s and early 90s, the legacy of these efforts remained strong. In many ways, the groundwork laid by these missions helped shape the post-Soviet era of international space cooperation. The engineering lessons from Buran and Mir influenced the development of the International Space Station, while Russia's continuing contributions to crew transport and orbital operations have kept that legacy alive. Though the Soviet Union is long gone, its bold strides into space still echo in today's global space programs. Whether through technology, scientific insight, or sheer ambition, the Soviet space program left a lasting mark, not just for Russia, but for humanity's shared journey into the cosmos. Have you watched or seen the re-entry of the Soviet spacecraft? Share us what you think in the comments section. Thanks for watching and subscribing to the channel.